Hi, I'm Eric. I'll be talking a little bit about part one for our SIR model project. Now, question one of part one asks us to examine the continuity of I prime. And as you can see by this graph here, it appears that I prime is continuous, but we can know this for sure because a SIR model is modeling a constant population over time. So apart from just looking at the graph, we can know that there will be no holes or any breaks in continuity over the duration of time for the infected people. Now, the second question asks us to take a look at the peaks in I, or where I prime is equal to 0, as I've outlined on that graph there. Now, a peak in I prime is a high point in the rate of infections, and you can see that on both sides the rate of infections is lower than where it is at that peak. So that's the maximum point at which the number of people who are infected. Now, question three asks a little bit about S sub t, and we can actually create a formula for S sub t using what is given to us. On the first page of the project, we are given a formula. I prime of t is equal to ASI minus BI. Now, since we know that I prime of t is equal to 0 at the I peak, then we can set ASI minus BI equal to 0. After that, using some algebra, we are able to determine that S sub t is equal to B over A, where B is the recovery coefficient and A is the transmission coefficient. Now, for question four, we are asked to examine the relationship between S and S sub t. So you can see that to the left of the I peak, S is greater than S sub t, and to the right of the I peak, S is less than S sub t. And you'll also notice that there's a trend in infection rates. So the infection rates are increasing when S is greater than S sub t, and they're actually decreasing when S is less than S sub t. And this is because when there's a higher susceptible population, then it's easier for the disease to spread and for infection rates to be high. But when there's a low susceptible population, the disease cannot find new hosts and the disease dies off. And that's actually examined a little bit in the fifth part here. So the fifth part talks a little bit about S sub t and herd immunity. And basically, herd immunity occurs when a large portion of the population has become infected and is therefore immune to being infected by that disease again. And as you can see by the graph here, that slows the rate of infection. When you see that about to the right of 30 days, you'll notice that the susceptible population is approaching 0, and that's also when the infected rates begin to fall. So basically, when herd immunity is achieved, this means that there's fewer susceptible people and that the rate of infection will eventually go all the way down until the disease dies off. So thank you for listening to my part of the project, and I hope you learned a little bit about SIR models.